Okay. Another nomenclature problem. If you know the polyatomic ions, then you should be in good shape for the nomenclature exercise here. You also have to be able to name molecular compounds, and so there's a problem on that. And so what we're going to see here are we're going to see compounds, ionic compounds that are made from acid anions, and additionally, we're going to have hydrates. And of course, then there's going to be at least one where we've combined hydrates and acid anions together in one ionic compound. So remember, an acid anion just gets the word hydrogen attached to the front of it, and depending on how many there are, so for instance, in the very first one, we've got a sodium ion and we've got hydrogen sulfite. And so in order to put together that name, I would use the rest of the ionic compound naming rules. So I would have sodium, hydrogen, sulfite. That's all there is to it when it comes to acid anions. If you know that it's SO3 is sulfite, you know that there's one hydrogen, so it's hydrogen sulfite. Looking ahead to some other examples that aren't on this particular problem set, you could have two hydrogens, like on a phosphate. So H2PO4 minus, that's an acid anion. It comes from phosphate. There are two. Again, here's the formula, H2PO4 minus. There are two hydrogens, so this guy is dihydrogen phosphate. That's all there is to acid anions. The next one is a hydrate. It's nitrite and chromium ion together, but we don't know the charge on chromium ion because it's a transition metal. But we do know the charge on nitrite is -1, and there's two of them. So the charge on chromium must be +2. So it's chromium 2 nitrite. And then I need to tell the reader how many waters of hydration there are. And so I say dihydrate. So it's chromium 2 nitrite dihydrate. Okay, and so let's take a look at the next one. What do I have there? I have a pair bromate. And pair bromate, we know the charge, we don't know the charge on iron. There are two pair bromates, and there's -1 for each pair bromate. So the charge on iron must be 2. So it's iron 2 pair bromate. And now we have to tell the reader how many waters of hydration there are. So it's pentahydrate. Okay, what's the next one? It's cadmium and acetate. Now, cadmium is one of those exceptions. It is a transition metal, but it always forms cadmium 2+. Acetate is -1. That's why there's two acetates. We don't have to include the Roman numeral. So this is cadmium acetate tetrahydrate. Let's make that a little better. Tetrahydrate. All right, so the next one is that example of H2PO4 minus dihydrogen phosphate, and it's with potassium. So the name of this thing with the potassium ion would be potassium dihydrogen phosphate. Okay, so the last one puts everything together. It's got an acid anion, and it's got zinc in it, and it's got some water in it. So The zinc is a transition metal, but it's one of the exceptions. We know that it always forms a +2, so we don't need Roman numerals for it. So it would be zinc, and it's with the acid anion from carbonate, and so it's hydrogen carbonate. And it's got 7 waters of hydration. So it's zinc, hydrogen carbonate, heptahydrate. All right, that's a big name, but it tells you everything you need to know to write down that formula. And so that's it.